start the recording, and let me share the screen. So people, since the schools are closed until further notice, we are going to actually it's not going to affect you as well. Anyway, like we are doing it anyway online, right? But for other classes, I have to go on the online as well. So but anyway, your class is going to be online with or without corona, right? Okay, so today we are going to quickly finish the programming part, or like the theory part for the programs, or the programming lesson. Then we are going to jump to the second one, right, which is a system development, right? So last week I gave you some homework to be done regarding the notes. I hope you have note down entire thing, right? So today we have to talk about this programming and scripting as well as language translators, right? So programming and scripting, now it's like even though it seems looks alike regarding programming and scripting, there are differences, right? So programming means, like I told you, like the Pascal is a programming language. So we have to tell, or we have to illustrate each and every instruction to the programming language, right? How to perform some particular task, right? But when it comes to the scripts, right, these scripts are like predefined building blocks, right? So we are given some building blocks and we are going to create some output or some creation using that building blocks. We can't change the way that the building block is, right? Building block එකේ විදිහ අපිට වෙනස් කරන්න බෑ. Building block එක cube එකක් විදිහට නම් එන්නේ. So it is cube. So we have to use the cubes and create something, right? So but programming language, it's not like that, right? And it should compile, and once it is compiled, it can be understand by the computer. Scripting language should be interpreted, right? So that is the major difference of the programming and scripting. So programming language, they need to compile it, right? And scripting language, we have to interpret it, right? So there are a lot of scripting languages. The famous two is the JavaScript and the PHP, right? So now, since we came to the words, or like the terms called compiling and interpreting, so it is the time for us to talk about the language translators. Now, compiling and interpreting is something performed by this compiler and interpreter, which we get to know as the language translators, right? So there are language translators. Earlier we say that the assembler is the language translator that used to convert assembly language into the machine language. But later we consider the assembler as one of the type in interpreter, right? So hold on, there are two other people logging in. Right. So now when it comes to the interpreter and compiler, right, there is a one major difference of interpreter and compiler. Now, if you need to remember about an interpreter, just remember a human interpreter, right? Human interpreter. सामान्य भाषा परिवर्तन करना मनुष्य ගැන මතක තියාගන්න. So that human interpreter, what the task of is like, let's say we have this English person, and we have a person who do not know about the English, right? So let's say Sinhala talking one and a English talking one is there, so they don't know anyone. Any of them does not know the other one's language, right? So English one does not know about the Sinhala, and Sinhala one does not know about the English. So to communicate for them, they need an interpreter. So interpreter is what interpreter is doing. If the Englishman need to communicate with the Sri Lankan in Sinhala, Englishman will tell a sentence to the interpreter. So interpreter knows both the languages. So he converted into Sinhala and let the Sinhala person hear that, or he says it in Sinhala to the Sinhala person. Then later Sinhala person will give the response, and according to that, the response is captured, or like the response is interpreted, right? So the same can be done, the same is doing by the computer interpreter, or the language translator called interpreter. What they are doing is, if they got 10 lines in the source code, so that source code will be translated like to be understood by a machine. So that means into ones and zeros, line by line. So one line of a source code is taken, then it is interpreted into the machine language. So it will definitely be more than one line from ones and zeros when it comes to the like the contents of a one line in third generation languages, right? So it happens like that. Third generation language එකේ එක line එකක් කියලා කියන්නේ ones and zeros එලි ගොඩකට, right? So once they're done with it, it is we can go with the like interpreter will go with the second line, right? So line by line, interpreter will interpret the things, but compiler is not translating one by one. Instead of that, compiler will take the entire code and will convert the entire code into the object code, right? දැන් මෙතන ටෝටල්ම පින්තූරේ පෙන්නලා නැහැ. මෙතන අපිට සරලව හිතා ගන්න තියෙන්නේ like this particular program is there. That particular program is completely compiled or completely converted into ones and zeros by the compiler. So it can be read by the machine, right? So interpreter line by line interpreting, compiler the entire code interpreting, right? So now this is the thing that the interpreter is doing when he is translating. If there are no syntax errors in the program, the statement will be executed. If there are syntax errors in the program, it will not execute to the end. It is possible to operate it till the error is reached. Yeah. So then api interpreter කෙනෙක් පාවිච්චි නොකරට ඒ concept එක අපි පාවිච්චි කරනවා, right? එතකොට ඒ concept එකට අදාළ වෙන විදිහට වැඩ කරගන්න විදිහත් අපි computer science වලදී කතා බහ කරනවා. ඒ කියන්නේ මේ line by line execute කරනවා කියන එක. දැන් ඔයගොල්ලෝ if you take the Pascal coding, right? So Pascal coding, if we have any syntax errors, it will run until the syntax errors, right? Then when the syntax error is found, it will tell what it is. But then මෙතනදී interpreter ගේ වෙන්නේ line එකෙන් line එක යන එකනේ. compiler ගේ වෙන්නේ the object file is there. කියන්නේ source code එක හරි වුණත් වැරදි වුණත් එයා executable code එකක් හදනවා. So when that executable code is executing, it can have problems, right? So like let's say at the 10th line, it can have an error, syntax error එකක් තියෙනවා කියලා හිතන්නකො. So first 9 lines will be interpreted. ඒක program එක run වෙන විදිහටම run වෙනවා. So once they found the 10th line, it will stop executing and telling you, okay, there is a problem. So you just do the mend it or debug it and rerun it again. Now, when it comes to the compiling part, entire code will be translated into the ones and zeros with or without errors, right? And then once it is running, we are going to check where we can find the errors, and if an error found, again that particular program set need to be compiled or recompiled, reinterpreted again, right? Okay, so let's write about the interpreter first, right? So please have the heading language translators. Yeah, and these 3 lines, those are important. So it's better you copy those down to your book now. Oh, people, we didn't wrote about the programming and scripting. So once we're done with the language translators, let's go for the programming and scripting, right? Let me know when you are done, people. Dulagi, like you are talking about this particular thing, not the interpreter, the compiler. If there are syntax errors in the program, it is not be translated to machine code. These errors are highlighted. Yeah, we'll come to that, Dulagi, once these things are over. Right. So now let's come to the that particular question of Dulagi. Now, I hope you have written onto this particular thing, and it's better if you can underline this particular things from here to here, because when a language is written in assembly language, it needs a special translator called assembler, right? ඒක පස්සේදී අපි කතා කරන පස්සේ කියලා කියන්නේ ඔයගලන්ගේ level එකේදී නෙවෙයි, when we clarify it later in advanced ICT lessons, they tell assembler as an interpreter as well, right? Right. Then interpreter and compiler. Let me illustrate this to you using a small diagram. What happens, right? Just a second, I have to answer this. Right, now if we take the same program, right, let's say same instructions, right, not the same program, right, same instruction, like it's going to give us the same output, right, written written in two different languages. One is from a programming language and one is from a scripting language. So both will execute the code to be run or to show the output of your workings of your source code, right? So what will happen is, now let's say this is the source code. Source code means then අපි Pascal වලින් ලිව්වනේ codes, ඒ file එක save කරාම ඒ file එකට අපි කියන්නේ source code එක කියලා. So now there will be instructions, and let's say this particular line contains an error, right? And if I choose the interpreter, not you are choosing, if my programming language or the scripting language uses an interpreter, so what we'll do is, now once we interpret, since this is a high level language, there will be a lot of ones and zeros generating. Likewise, this particular one will be generated, and it's not like one particular ones and zero row to one particular black line, right? It will generate many ones and zeros per one particular line, right? So anyway, like when the interpreter, right? So now interpreter is at the middle, so it will be taking the source code and will convert it into the machine code, right? So this is the machine code, right? And if no error is found, if no error is found, you will be seeing the program will start and run normally and will give the output as the program states, and program will end, right? And if you take the compiler, same happens. If no errors found, you will be seeing, okay, program is starting, it is running, and it will be giving you the particular outputs. The case get differs when you are having an error. Now, if it is interpreter, now this machine code is happens, right? So that means we will be able to see something on the screen. Right? Some output on the screen. And when the error is found, now let's say error point is going to be right over here. So then this is going to give us an error message. Right? Right? And these lines is the output until error finds, until error occurs. Right? So this is the way it's going to translate. So you can see program is up and running, and whenever the error is found, the error message is given, right? That is why it says if there are no syntax errors in the program, the statement will be executed. If there are syntax errors in the program, it will not execute it to the end. It is possible to operate it till the error is reached, right? So this is what happens. So output will be generated until error occurs, right? I'll describe this much further. Output generated until error occurs, right? So if it is the compiler, the picture gets a different thing. If this is run through a compiler, right? Now, compiler will not give any output until the entire source code is being compiled, right? So as usual, this will create the object code or the machine code, but it won't give any output. That is why it says if there are no syntax errors in the program, code is translated to the machine code. If there are syntax errors in the program, it is not be translated to the machine code. These errors are highlighted, right? අපි ඔතනදි කියනවා මේ කියන්නේ ones and zeros මේ machine code එක පැත්තටම එන්නේ නැහැ. object code එකක් හදා ගන්නවා කියලා. ඒක ටිකක් intermediary code එකක් කියලා අපි කියන්නේ. ඒතර object code එක මැදදී it will highlight the error. Right? So if this got an error, we can illustrate it like this. Let's do not go for the machine code. Right, so here output an error message without executing the program. In other words, it is not being converted into ones and zeros, right? And compiler is trying to compile the entire source code into the machine code. එහෙම කරන්න හදන නිසා තමයි මෙයාට මග error එකක් හම්බුනොත් මෙයා කිසිම එකක් output නොකර ඉන්නේ. හරියටම ඔක්කොම convert වුණොත් හරියටම ඔක්කොම compile වුණොත් තමයි machine code එක විදිහට එයා නැත්නම් execute වෙන විදිහට ඒක user output එක පෙන්නන්නේ. Right? Got it, people? Yes, is it clear? Right. අපි මෙතන මේක මේ විදිහට ගියා නම් හොඳයි කියලා හිතෙනවා. මේ curly brace එක අපි දාගමු මෙතන ඉඳලා මෙතනට. ඒ ටික output එක create කරන්න උදව් වෙන කෙනා. Right? From this point, it will show us the error message. Right? Okay. I want you to yeah, hold on. Make a දාගන්න තැන අපි දැන් මේ දෙන්න ගැන ලියාගත්තානේ. Yeah, you better draw this. You better draw this. Then at the right below this thing, I'll tell you what is happening. Let me know when you are done, people. People, are we done? People, are we still drawing? Everyone? Okay, two are done. How about others? Three are done. Okay, so let's move to take down the important things, right? Yeah. Now, yeah, like under the diagram, just put a subheading called interpreter and start it over here, language translator, which translate each and every statement written in a high-level programming language to machine language commands one by one. Yes, people. Yeah, the next line is also very important because it says it executes instantly. Write that two lines. And as the second point, write this because we know if there is no errors, it will execute until the end. So as a second point, write the other highlighted part. Right. One is done. How about others? All right. Then let's move to the compiler part. So, yeah. So regarding the compiler, start from here, translate the entire program written in high-level language to machine language as a whole before it could be executed. And this is the next line that you need to write. Right. Okay. Right. So that's all, people, regarding the translators, and we write what we missed under the programming and scripting, right? Yeah. So under the programming and scripting, it's better you copy the entire thing. Yeah, Dulagi now. It's like this Dulagi. Eka apita simply විස්තර කරන්න අමාරු දුලාගේ අහන ප්‍රශ්නේ තමයි why programming languages should be complied and scripting languages should be interpreted කියලා. Like I said දුලාගේ programming language දැන් මෙතන මේගොල්ලෝ මේ explanation එකත් කියලා තියෙන්නේ. There are hard and fast syntax rules. Like when we are creating a program using a programming language, we have to write each and everything according to our logic, right? But when it comes to the scripting language, it's like some of the codes has given already. Then ඔගොල්ලෝ අන්තිම පාඩමට කලින් පාඩම HTML ගැන ඉගෙන ගන්නකොට it's a scripting language, right? So there are some predefined tags for us to get used as they presented us. ඒගොල්ලෝ දීලා තියෙන විදිහට අපිට පාවිච්චි කරන්න වෙනවා. Right? එතකොට එතනදී compile කරන්න ගියොත් අර already හැදිලා තියෙන දේවල් ටිකත් compile කිරීමේ අවශ්‍යතාවයක් එනවා. Right? So scripting will be much effective. Like scripting language will be much effective if they are doing it in a interpreting manner. එතකොට මොකද ඒගොල්ලන්ට holder එක අතරමැද්දේ තියෙන දේවල්. කියන්නේ scripting language එකේ already හදලා තියෙන building blocks ටිකෙන් අපි හදන්න යන structure කොටස විතරයි convert කරගන්න ඕන වෙන්නේ. Right? So එතනදී interpreter කියන එක much efficient. Compiler ට දුන්නම it's going to compile the entire thing from the beginning. Right? ඕක දුවට තව HTML එහෙම කරලා එනකොට grade level වල නෙවෙයි, right? තව අපිට කියවලා දැනුම එකතු කරගන්න පුළුවන් කොහොමද කියන එක. The major difference is going to be like that. Since it is the programming languages are having hard and fast syntax, so we have to like convert entire thing from top to bottom, right? So like the almost everything, right? But in the scripting language, there are some predefined blocks or codes which we can use to get our thing done, right? ඒක හරියට අර අපිට building blocks දීලා robot කෙනෙක් හදන්න කියනවා එකයි ඔයගලන්ට වැලි හරි මැටි හරි දීලම same robot එක හදන්න කියනවා කියන එකයි, right? So වැලි මැටි දුන්නයින් පස්සේ නේද අපි ඒක mix කරලා pulp එක හදාගෙන හරි block එකකට it has lot of work. Have a built-in block එක it's easy to interpret, right? ඒක අපි අර වැලි මැටි විදිහටම කරන්න ගියොත් නේද match වෙන්නේ නැති වෙලා යනවා නේ. So that kind of a thing. ඒ කියන්නේ දැනට දුවට දෙන්න පුළුවන් උත්තරේ ඔන්න ඔය විදිහයි. right? Got it to right. Okay, so people, the first lesson is done. So we are moving to the second lesson, which is the system development life cycle, right? Okay, have the heading system development life cycle. අපි කෙටියෙන් මෙයාට කියනවා SDLC එක කියලා. Right? Now in this lesson, we are going to learn what are the things to be done when we are creating a system, right? Like in simple words, if we are planning to develop a software which is going to be a system, what do we need to concentrate on, right? System එක කියලා කිව්වම software එකෙන් එහාට ගියපු කොටසකුත් තියෙනවා. ඒ කියන්නේ ඒක softwares පොඩි පොඩි ඒවා ගොඩක එකතුවක් වෙන්න පුළුවන්. Right, so think about an ATM system, right, a payroll system, an internet banking system, right? So it's a collection of a lot of things, and again in much simpler word we can say it's again going to be a software, right? So write the heading system development life cycle, and first they are talking about the concept of information systems, right? Now this particular line is a very important line. It will be there in your examination as it is. If they ask you to write what is a system or write the definition of the system, this is going to be the definition. A system is a collection of components that interact to achieve a specific task, right? So we talk about this in the very first lesson, if you can remember, of the grade 10, right? Now, what they are trying to illustrate using these two figures, like when this robot is dismantled, or like when they decompose the robot into many different parts, they are not interrelated or like having the interaction with each other. So robot won't be able to function or to give the output that we need. So to take an expected output from a particular system, there should be component which should be able to interact, right? And robot මෙහෙම arms දෙක connect කරලා නේද එයාගේ body එකයි ඊළඟට එයා control කරන circuit එකයි connect කරලා තිබ්බම තමයි, so he can move and turn and like do whatever the thing that we are expecting the robot to do, right? If they are not in a position to interact, then it cannot reach its goal or cannot perform this specific task, right? So specifically, if we are going to address something, a system, it should be a collection of components that interacts to achieve a specific task, right? So if you take a robot, it will be given a specific task, right? These are the things that you can do, right? So it will only be able to perform that particular tasks, and with the components given, it will always try to achieve that thing, right? So that is what we call system. And in other words, there is another way of that we are talking about the system by saying a system will take inputs and will process things and will give outputs to us. So if you take the same example as robots, it will sense the things through the sensors like cameras, like heat temperatures, right? Like the moving wheels and all these things, right? So it will take the inputs from the cameras, from the microphones, right? From the sensors, and then it will process and will give an output, right? There will be voice command වලට වැඩ කරන robot කෙනෙක් හැදුවොත් එයාගේ input එක වෙන්නේ අපේ voice එක, right? So it will take the voice through a microphone to its system, the processor and the things which is inside the robot, and will process and will perform, right? මම ඔයගලන්ට ලබන සතියේ පොඩි වීඩියෝ එකක් පෙන්නන්නම් TV show එකක රොබෝට් කෙනෙක් introduce කරන එකක්. එයාට dance කරන්න ගිහම dance කරනවා, ඉඳ ගන්නකොම ඉඳ ගන්නවා. So everything it's the verbal communication that we are doing with that robot. So it input through a microphone which is inbuilt with the robot and process, and it acts according to our instructions, right? All right, so as I told you, these are the basic elements that they have introduced for the system, which is the input, process, and output. So if any particular thing can be modeled into this particular structure, which is the input, process, and output, we can call it a system, right? So as an examples, they have taken the school as a system, right? So the common objective is to produce a responsible, worthwhile, just citizen to the society. So input will be children. Process will be like the child is subject to teaching and learning process through interaction of teacher and the other resources. So the output is going to be providing a good citizen to the country, right? So the example two, the tomorrow's weather forecast, right? Uh, by weather forecasting system taking atmospheric pressure, temperature, wind direction, those will be the inputs. So according to those input, they will have a process. If the temperature is like this and the wind direction is like this and the humidity is like this, so tomorrow is going to be this kind of weather. So they're predicting it, right? So it is having an input, it is having a process, and it is giving us an output, right? When it comes to the information system, the input is going to be data, the data will be processed, and information is going to be the output, right? So specifically when it comes to the information system, data will be inputs, process, and the information can be taken as the outputs, right? Okay, shall we have a very little note about this? So I hope you have put the heading, and then write the first subheading, what is a system, and copy it under this particular point. Okay, are we done? People, everyone. Right, okay. All right, so let's moving down. So, yeah, yeah. Regarding the basic elements of a system, write it from this point to this point, right? Then it's better you have the first example. Right. Are we done, people? All right. One is done. How about others? Right. So we are moving forward. So when it comes to the information system, let's write about this thing. Not about the classification. We are going to write about that classification later. Right. And it's better you just mention it with these two. Right. So the information system and the clarification and the small diagram. Okay, are we done? Right. Okay. So at the latter part, people, they are talking about these information systems can be divided into two parts, which we call the manual system and the computerized system. So it's easy to understand. In a manual system, all the processes are done manually, right? So they are talking about a student manual student information system, a student information system which handles manually. So they talk about a scenario when a child is admitted, the school receives a register number, a file is prepared which containing the personal information, right? So that file will be like maintained or like record what are the special abilities and what are the achievements. And then at the end of the day, like when a child is going to leave the school, it will be considered to create his character certificate and all these things, right? So they decompose the process into these things, like the input is name of the student and the relevant year. So the processors is like find the index number of the student, find the personal file according to the index number, right? Extract the required information for the relevant year from the file, and prepare a report using this information. So these things uh, like can be done using the manual information file. Then ඕගොල්ලන්ගේ ඉස්කෝල ගැන හිතලා බැලුවොත් most of your school are still going on with this manner, right? So if you go and like ask for your copy of your birth certificate or copy of some particular certificates, they will access your particular file, which is a manual file, which is a like the file thing. ඇත්තම ෆයිල් එකක් අරගෙන ඒකේ තියෙන ඩොකියුමන්ට් එකකින් තමයි ඔයගොල්ලන්ව refer වෙන්නේ, like if they are like referring to your details regarding the school, like the day that you are going to admit, that the day that you were admitting, and your other details that was reported on that particular day, they will take a big logbook and will turn to your particular index number and give you the details, right? So your mostly that particular detail is found out with the help of your name and the index number, right? Or maybe the name and the relevant year. But in most of the cases, index number is there. So index number is a unique one. So it will be easier for them to find it using the index number, right? So the output, according to what you are requesting or according to the request, the output will get differ, right? If you are asking for a progress report, yeah, it can be the created, right? And if someone is asking what are the achievements that he or she has taken all over the year or the last year, so that particular thing can be processed and created. So that particular report will be the output, right? So that's in a manual system. So when it comes to the computer-based information system, right, things are going to get differ, which we are going to talk about it by next week, right? And then, of course, we are going to talk about how this particular system, which is going to be a computer system, going to get developed, right? With the help of SDLC, System Development Lifecycle, right? Okay, people. So next week there will be like writings like today, right? Yeah, when it comes to theory lessons, it's yeah, we got something to write, but here it is like very few things in the diagram wise that we have to go through, right? So I'll try my best to finish up the lessons by next week, because there are very simple things for us to talk about through the SDLC, right? Okay, so till then, I'm going to end the session for today, right? Thank you and have a very good night, right? And I'll meet you on next Sunday for the same time, right? Thank you very much, people. Have a nice weekend.
Thank you, sir. Bye, sir. Good night, sir.
Right, okay, Buddha. Thank you.
Thank you, sir.
Right, okay, Dua.
Thank you, sir.
Right, okay, Saran.